here is a 7th generation fighter jet that breaks all air war paradigms with hypersonic speed, AI technology, laser weapons, and stealth capabilities, capable of being manned or unmanned. Whilst the unknown invites speculation and inspires potential threats to world nations, the US has again shown its prowess by testing its new 7th generation fighter jet, shocking Russia and China. This is a development promising to usher in a new era of air supremacy, providing the US with an edge in air combat for years to come. While Russia and China are still building a 6th generation and master 5th generation fighter, the US is actively developing the SR-72, a 7th generation fighter, to create a successor to the iconic SR-71 Blackbird. What would a 7th generation fighter look like? How would it fight? Could this US technological supremacy in the air combat arena represent a significant threat to the rest of the world? Join us as we unveil the US-tested new 7th generation fighter jet and why this would cause shockwaves in Russia and China. Despite the increased secrecy surrounding the US's advancements, it is known that the development of the next 7th generation fighter is already in full swing. While the serial production of the 7th generation aircraft may not have begun yet, the initial operational capability (IOC) stage will soon commence after the launch of production sites for components and the creation of an assembly shop. However, the significant progress in hypersonics, space, sensing, and artificial intelligence (AI) occurred due to the emergence and increased use of digital and innovative technologies informing future fighters. The US Pentagon, therefore, worked on potential innovations and considered how these innovations could inspire the design of a 7th generation stealth fighter, as the 6th generation has already taken to the skies. At this stage, a major technological breakthrough was achieved in the aircraft industry that allowed aircraft creation 10 times faster than the previous record held by the F-22 or F-35. This breakthrough was made possible by implementing artificial intelligence, AI, at almost all stages of the aircraft creation process, from the imagination and set of combat missions to the simulation of actual combat situations based on real air battles. Remarkably, this marks the first time in the US military industry that the formulation of tasks was assigned not to generals, but to a neural network artificial intelligence. AI knows better what the future of warfare holds and what combat qualities fighter jets should possess. It has significantly accelerated the development process, particularly at the most challenging stages, typically consuming 90% of the total development time. Also, the AI has the potential to revolutionize the aircraft design process. Unlike human engineers and designers, AI can think of multiple aircraft designs simultaneously while performing strategic and tactical tasks. It can also stimulate the airframe and power plant, predicting the aircraft's performance in the air. Moreover, AI, with the help of reality modeling, can allow pilots to test the future aircraft. The most significant advantage of artificial intelligence in aircraft design is its ability to consider current technology levels and the availability of materials or alloys. This means that AI can build aircraft while considering the latest technological advancements. Human input is unnecessary for the Next Generation Air Dominance (NGAD) program. A person's role is to quickly provide the neural network with a wide range of data. High-ranking military personnel examine the AI-generated results, and both 6th and 7th generation fighters are created in parallel, ensuring they appear simultaneously. Lockheed Martin Skunk Works revealed some information about the SR-72 program, which is intended to be the successor to the iconic SR-71 Blackbird reconnaissance aircraft. This information exposes that the most challenging step associated with developing key technologies for the new fighter is already behind us. According to the Advanced Aircraft Development Division of Lockheed Martin, hypersonic technologies have advanced and implemented in the planned SR-72. Thus, the strike and reconnaissance aircraft capable of topping Mach 6 are being built using a combined cycle propulsion system that merges a supersonic jet engine with a rocket engine. Similar to the collection of technologies incorporated into the Mach 66 TF generation aircraft is the 7th gen advancements. This includes conformal sensors, blended antennas, a new level of AI-enabled sensing and computing, manned-unmanned teaming, smart skins with sensors woven into the fuselage, and a new generation of stealth properties such as coating materials, thermal heat signature management, and external configuration. The industry renderings of the 6th TF generation aircraft, one of which may be the demonstrator chosen, reveal a new, sleek, advanced, stealthy body type, and images of 6th generation planes show a fuselage with no vertical structures, giving it an ultra-stealthy horizontal blended wing body that looks like a B-2. The SR-72 concept is built upon the same premise, but aimed at achieving even higher speeds to grant it the same survivability against even the most advanced 21st century threats. Recently, the Blackbird achieved its stated top speed of Mach 3.2, although many pilots claim it was a bit faster through the use of its unique Pratt and Whitney J58 turbojet engine. The claim is based on the incorporated variable geometry nozzles, which manage inflowing airflow and bypass pipes extending out of the engine's early compressor stages to funnel air directly into the afterburner to increase thrust further. However, it would take an even more exotic form of propulsion to reach the necessary speeds for survival in the modern battlefield, as jet engine technology has improved dramatically in the nearly 60 years since the J58 engine was designed. Hence, to outrun current air defenses, the SR-72 must reach hypersonic speeds above Mach 5, which have only been accomplished with rocket-propelled aircraft, spacecraft, or single-use technology demonstrators. Although the conventional turbojet and turbofan engines can power an aircraft during takeoff and landing, but not at hypersonic speeds. Conversely, jet engines can power an aircraft at hypersonic speeds, but not during takeoff and landing. Both capabilities are crucial for the SR-72. In addition, the SR-72 program has been working to develop a fully reusable turbine-based combined cycle hypersonic propulsion system. This new air-breathing jet engine combines turbofan engines, commonly used in today's tactical aircraft, with a supersonic combustion ramjet, also known as a scramjet. Such an engine can reach and sustain speeds above Mach 5 and, in some cases, over Mach 10. Interestingly, this combination addresses the challenges of managing airflow at speeds ranging from a dead stop to high supersonic regimes. Also, air-breathing jet engines, such as turbofans, rely on a compressor fan near the inlet to draw air into the engine, compress it, mix it with fuel, and ignite it for propulsion. Also, these engines can accelerate an aircraft from a standstill for takeoff and reach speeds up to around Mach 3. However, their efficiency is limited at high speeds due to the compressor at the front of the engine designed to suck in and compress air, becoming a hindrance to the inflowing air. Ramjets and scramjets, on the other hand, lack a compressor and often any moving parts, making them inefficient at low speeds and unable to function from a standstill. Nevertheless, these engines become effective at speeds above Mach 3, utilizing the immense pressure of inflowing air to create the necessary compression to mix air with fuel for propulsion. To slow the inflowing air down to subsonic speeds and make it more manageable for ignition, ramjets use a blocking body of sorts in the inlet. Ramjets are generally capable of reaching speeds as high as Mach 5 or 6, but likely no higher. Modern scramjets allow air to flow into the engine at supersonic speeds without impeding it, making ignition challenging. Lighting a match in a hurricane is often used to describe this challenge. Despite this, scramjets are believed to be capable of reaching speeds above Mach 10 or even higher. A turbine-based combined cycle engine combines both turbojet or turbofan and ramjet or scramjet engines. This allows the aircraft to take off and accelerate to about Mach 3 before transitioning to the ramjet or scramjet to accelerate to Mach 5 and beyond. A visionary startup company, Hermes, was awarded the prestigious SR-72 contract for creating reusable hypersonic aircraft with a long-term goal of revolutionizing the worldwide human transportation network. Its success led to the potential to create a much faster and more efficient air travel system for the U.S. Air Force. The hypersonic technology being developed by Hermes has both civilian and military applications, making it a valuable breakthrough in aviation technology. The Mach-5 aircraft, developed by Hermes, can travel at speeds exceeding 3,000 kilometers per hour, making travel hypersonic, not just supersonic. This significantly reduced travel time, an innovative solution for our fast-paced world. Hermes has demonstrated the feasibility of their turbojet-ramjet engine concept in a high-speed wind tunnel. However, a joint team from Lockheed Martin's Skunk Works and Aerojet Rocketdyne may have quietly exceeded their achievement by years in developing a similar technology. When comparing the 6th-generation fighter to the 7th-generation fighter, it's important to consider several distinctive features of the 6th-generation fighter. One such feature is its capacity to carry high-energy laser weapons. While current laser weapon systems exist, they still lack the necessary power. As a result, for now, the primary weapons for the 6th-generation fighter will continue to be various missile types, including hypersonic missiles. However, the fighter must have the ability to carry laser weapons to be equipped with them once the technology develops to meet the desired level of effectiveness. Another notable feature of the aircraft is its variable cycle engine, equipped with state-of-the-art adaptive technology. Lockheed and Aerojet Rocketdyne have worked together to develop a combined cycle propulsion system that can operate at speeds lower than Mach 3. The engine system employs a turbojet engine for hypersonic mode, while a ramjet engine starts and creates thrust by sucking in air while moving at hypersonic speeds. This unique engine system utilizes the same air intakes and exhaust nozzles for both turbojet and ramjet modes, eliminating the need for any changes in the initial configuration of the aircraft during flight. Additionally, the aircraft is designed to be radar stealthy and employs a set of measures that include the profile and design of its airframe and the application of special coatings. The onboard equipment also plays a significant role in the aircraft's stealth characteristics, neutralizing enemy low-frequency radars that can otherwise detect stealth aircraft. One of its most significant qualities is its ability to transform and solve specific combat missions. This is done through a system of interchangeable blocks with equipment that can be installed, dismantled, and replaced by others on board the fighter. This allows the aircraft to be adapted to perform a specific combat mission, making it a valuable asset in various situations. Moreover, the unmanned control function is another significant quality of the 6th-gen aircraft. The absence of a pilot in the cockpit enables the aircraft to operate in hypersonic flight modes, thus expanding its maneuvering capabilities. In some maneuvers, the aircraft may experience monstrous overloads inaccessible to the human body, but the unmanned control function allows the aircraft to perform such maneuvers seamlessly. This feature makes the 6th-generation aircraft highly advanced and capable. A unique feature of 7th-generation fighters is their cockpitless design, which allows for a cooling system that caters to services and units that experience high thermal loads. These fighters possess exceptional qualities that differ from their predecessors and are primarily intended for near-space operations. They are designed to operate on the border of the most advanced air defense systems, such as Russia's S-500. They can fly 124 miles above sea level, making them a vital asset to any modern air force. Their flight altitude and superspeed are crucial to their performance, which is more important than their stealth characteristics. The 7th-generation fighter aircraft is expected to achieve hypersonic speeds, requiring a specific design to meet the aerodynamic requirements. It is anticipated that the creation of this aircraft will resemble the T-65 X-Wing space fighters from George Lucas's Star Wars. However, unlike the space fighters, the 7th-generation fighter will primarily operate in atmospheric conditions rather than airless space. The aircraft will periodically exit near space, putting it through significant mechanical and thermal loads. Therefore, the structure of the 7th generation fighter must be designed to withstand these harsh conditions. It is expected that the airframe of the 7th generation fighter will consist of heat-resistant steel alloys, titanium, ceramics, and composites to meet these requirements. Furthermore, the 7th generation fighter aircraft will be equipped with a swept ring and volumetric air intakes, and its payload will be placed inside the aerodynamic fuselage to eliminate additional heating points during hypersonic modes. This fighter jet can deliver lightning strikes against high-priority targets with this design. This advanced aircraft will be able to cross the Atlantic Ocean in just 1 hour thanks to its hypersonic speed capabilities. The flight of the 7th generation fighter will take place in the subsonic, supersonic, and hypersonic ranges, positioning it somewhere between the SR-71 Blackbird and the Lockheed SR-72 in terms of design and capabilities. The combined cycle power plant that Lockheed and Aerojet Rocketdyne originally built for the SR-72 has enabled the development of a hypersonic fighter aircraft. This system is needed because conventional turbojet engines cannot attain the required speeds for hypersonic flight. However, utilizing a single ramjet engine is not practical as it necessitates an initial acceleration. To tackle this issue, Lockheed Martin and Aerojet Rocketdyne have developed a ramjet engine that allows hypersonic flight. This innovative technology has paved the way for developing advanced aircraft that can travel at incredible speeds. It is important to note that hypersonic speeds are detrimental to the pilot, and hence this fighter aircraft will be remotely controlled in an autonomous unmanned mode. During hypersonic flight, radio communication with the ground operator is practically impossible, making it necessary for the aircraft to be controlled by an autopilot. The onboard combat control system will be responsible for solving combat missions. The 7th generation fighter's onboard system is designed to be connected to the Link 16 network, a tactical data exchange network that facilitates communication between participants in combat operations. This network includes a wide range of participants, such as satellites, warships, submarines, aviation drones, and artillery, enabling coordinated actions at both the tactical and operational levels. Conventional bombs and missiles used by the U.S. Air Force are unsuitable for near space, so developers need to focus on energy weapons. The 7th generation fighter is expected to deploy energy weapons to target enemy satellites and ground objects of strategic importance. For instance, a powerful laser can disable nuclear power plants and reactors, and hypersonic missiles are also being considered. Furthermore, the 7th generation fighter could be the first stage for launching weapons such as rockets, which do not require a booster engine, making them more compact and cost-effective. This new fighter is poised to impact the future of combat operations significantly. The 7th generation fighter aircraft is predicted to be highly advanced and sophisticated, although it is expected to be more expensive than its predecessor, the 6th generation fighter. The cost of each plane is estimated to be several $100 million. The United States is the only country with the financial capability to afford such expenses. Critics who question the large military budgets need to consider that not all countries are allies of the U.S., and maintaining military might is necessary to protect against potential aggressors. Noting that the U.S. was the first to develop a 5th generation fighter, and the Lockheed Martin F-22 Raptor, introduced in 2005, is a prime example of this. The U.S. aerospace industry has successfully established serial production of such aircraft, and it is the only country in the world operating 2 types of 5th generation fighters. Also, the United States Air Force, Navy, and Marine Corps are equipped with a 5th generation serial fighter named the F-35 Lightning II. This fighter is even more massive than the American F-22 Raptor. At present, the F-22 Raptor and F-35 Lightning II have no competitors. However, the Russian Su-57 exists in triplicate, with 2 undergoing testing and only 1 Su-57 currently ready for operation. One of the primary challenges associated with serial production is the need for a suitable engine. China also has 5th-generation fighters, with the Chengdu J-20 being built in 150 copies and the only Shenyang J-31 currently undergoing flight tests. Thus, the Chinese developer is facing issues related to their power plant. However, it's important to note that this situation is temporary. Likely, both Russia and China will soon develop 1,000 fighter planes, and it is never too early to contemplate advanced aircraft technology. Given this development, the United States must develop 6th and 7th generation fighters that can retain the advantage enjoyed by today's fighters. With the advancement of technology, it is possible to create a much smaller and stealthier platform that can possess equal or greater lethality. Miniaturizing sensors, computers, and weapons can achieve this. The idea of a stealth fighter operating beyond the Earth's atmosphere and conducting combat and surveillance operations in space is plausible. Considering that the 7th generation aircraft has the potential to fly at hypersonic speeds, it is a versatile and efficient option as it can travel beyond the Earth's atmosphere and back on a single tank of fuel. These aircraft can operate as air and space attack platforms, with the capability to destroy enemy fighters, satellites, or missiles. Therefore, the ability of these stealth fighters to perform these advanced operations will truly revolutionize the future of air and space warfare. In fact, the U.S. ability to test the new 7th generation fighter jet is a remarkable development that would cause any country, and not only Russia and China, to panic and re-strategize their aviation due to the potential threat posed by such advanced technology. Thanks for watching. While you're still here, click on the link on your screen to watch another of our exciting videos. See you there.